Welcome to ClickMyProject.com. Now we discuss about the product for novel VLSI architecture for real-time medical image segmentation.
Next we see the abstract for the product. The implementation of DSP application in VLSI enhanced over the past decade due to the advance in VLSI tools. Application-specific integrated circuits and programmable DSP processor were the carrier implementation of platform for many applications. But reconfigurable computing is considered as the best implementation environment due to the availability of reconfigurable tools and functional efficiency of hardware. The merits of such as the high-speed performance due to the parallelism and pipelined reconfigurability, low design cost due to the replications, low energy dissipation per computation as made to FPGA-based implementation is the best suited platform for many depending areas of such as DSP, image and video processing. The role of segmentation is that medical imaging is the more significant in the diagnosis and treatment of many diseases. Segmentation of medical images is a challenging task due to the poor contrast and speakable noise present in the images. Computation of accurable hardware architecture is, for the segmentation of automatic structure of medical image is also challenging the problem. The segmentation of anatomic challenging problem, the structure is essential first stage of most medical image analyzing tasks such as the registration, labeling and motion tracking. Segmenting the structure from the medical image or reconstructing geometric representation of compact structure is also difficult task due to the sheer size and the datasets of complexity of variability for the another shapes of the overall medical image segmentation process. The image segmentation plays the important role in the processing of medical images. Segmentation is medical image is a challenging task due to the poor image contrast and the diffusion of organs or tissues boundaries. Due to the emergence of the new trends in the engineering technologies, many medical diagnosis methods are automated using the image processing principles. Hence, in this paper, hardware implementation of segmentation of the brain tumors is carried out using the Xilinx system generator and the FPGA. Yet the result is generator performance less design time and cost than the existing programmable digital signal processor or than the even PC with the coprocessor due to the lot of parallelism and pipelining. Use the Xilinx system generator for medical image processing application effectively reduce the intricacies existing in architecture designs and also provides additional features of hardware simulations. Medical images in the raw form are represented. The array of number of in the computer indicates the contrast of different type of body tissue. Processing and analyzing the medical image are useful to transform the raw images into the qualifiable symbolic from the ace of search and mining. It's extracting meaningful qualitative information to aid diagnosis and interacting complementary data from the multiple imaging medicals. Next we see the flow diagram for the product. Browse the given any one of the input medical images and to passing the image pre-processing module function. Our Simulink based design module function to be consider the fixed size of overall architecture process. So we convert the 250 to reshape the 256 cos 256 matrix size and to apply the serial manner in the our overall architecture functions in a separate buffer memories allocations. The buffer memory allocation each and every processing to be allocated in the same time manner and to apply the Xilinx system generator based Simulink design. This design to apply the threshold segment selection identification based process for overall architecture. This segmentation architecture to identify the boundary identification of Xilinx and Simulink based blocks. This block used to identify the edges for overall medical images and to identify the different edges and to set the different threshold function for our Simulink based designs. This design to convert the more architecture based process for our overall Simulink design. Then to apply the post processing module, the post processing module to be reconstruct our overall image
in the pre-processing module and the reverse adder manner, and to apply the system generator function to be converted into the VHDL code or Verilog code, the converted VHDL code generation, and to simulate and synthesis the our VHDL code using the Xilinx based software, and to analyze the RTL and technological diagram for image segmentation in using FPGA based simulating block design, and to identify the hardware requirement of our overall Xilinx process. Then we see the MATLAB oriented simulating design process, and to result image for segmented image to be identify the our overall architecture. This is our the final flow diagram for the image segmentation process. This is the final output for the our overall product. This is our the design for final sample design. This design to be considered for the pre-stage and post-stage process for image segmentation process, and we use the different type of architecture for segmentation process. We identify the edge detection based process, and to detect the our overall image based segmentation detection work for our required final design oriented process. This design process consists of the most number of simulating based designs of to be represented. These all the blocks to be based on the Xilinx oriented block. And this block to be converted into the VHDL code using the system generator process. This is our the final output for our overall architecture. This architecture mainly based on the this running based process. This is our the various image segmentation part. This is the input image for our overall segment medical image process, and this is the segment part for one of the type of architecture. This is another one type architecture. This is the different type of four type of architecture to be present in our overall simulating based design. This is our the overall edge based simulating image segmentation based process using the FPGA oriented simulating design based process. This is our the simulating based Xilinx converter block. This is our the Xilinx coding, and this is the RTL diagram for our required image segmentation process. This is the image segmentation process to be converted into these oriented blocks. This is our the RTL diagram for our required IC for image segmentation process. This is our the technology diagram for our overall architecture. Then we go to the design summary process. This is the technology diagram to represent the how many blocks to be presented in our overall IC architecture design, or the lookup table and the input output buffer and the gating element for our required architecture based process. Then go to the design summary process. The design summary process to be represents the how many hardware to be required for our overall image segmentation, and what are the timing to be presented for our overall architecture based process. These are the things are to be represent our the Xilinx oriented block. Our design to be converted into this coding, and to represent the timing and synthesis report generation for our overall architecture for required FPGA based simulating design based process. This is our the final output for the product.